Are you sure?
Yes. Why don't you just go take a nap and then it does sound nice.
Is the sun?
Alright, today we are going to talk about geometric series. Okay? We have already talked about arithmetic sequences, arithmetic series, and geometric sequences. So what was a series? Just before we start talking about geometric series, what was a series in general? So that was more a sequence, like a list of numbers. A series is when I add a list of numbers up. Right? A series is when I add a list of numbers up. So then a geometric series is just adding all of the numbers in a geometric sequence together. Okay? The sum of a geometric sequence. Now this is the formula that we are going to use to find that sum. Okay? Adding all of the numbers up in a geometric sequence, okay, to create a series. So the sum of the first n terms is equal to the first term times 1 minus the common ratio to the nth power over 1 minus the common ratio. Okay, that's going to get me the sum of the first n terms in a geometric sequence. Okay, so copy this down here real quick. And then we'll take a look at some examples. Got it? Alright, so to use this formula, jot this down up here so we have it. To use this formula, we need three pieces of information. Right? We need the first term, the common ratio, and the number of terms. Right? So I want to collect those three pieces of information. So say n, first term, and the common ratio. So the way this problem is asked, okay, it gives me the first 4 terms in this series. It tells me to find the sum of the first 14 terms. So that's my n value. Okay, right here. If I want to find the sum of the first 14 terms, that tells me that n is 14. Right? My first term then, you can clearly see, is 4. How do I figure out the common ratio then? What was the common ratio? Yeah, the common ratio is the number that we're multiplying by every time. So the easiest way to get that is take one number and divide by the term before it. So 20 divided by 4 is 5. 100 divided by 20 is 5. So my common ratio is 5. I have all 3 things I need now to plug into my formula. So I can say the sum of the first 14 terms is equal to the first term times 1 minus the common ratio, which is 5, raised to the nth power, which is 14, all over 1 minus 5. So what do we get when we plug that into the calculator? be a pretty large number. Negative 21.
Isn't it like 6,100,515,000?
Wait, you said 6,100,000,000.
No, 103,515,000.
Wait, what was the last part? 624. Is that what everybody else got? No.
I don't know what I do.
I don't think it should be negative 21. It should be a pretty big number.
Oh, you're missing a set of parentheses. So it raised 5 to the 14th power. And, oh, well, it is 5 to the 14th power, never mind.
I don't know if I got the same one I think I did.
Yeah, that's what it is.
Oh.
Because I have a place that parentheses you can see at the end. I don't think you need it.
Yeah, I think that should be our answer.
Yeah, everyone stops second guessing.
Yep.
Marshall.
Alright, so that's it. Alright, that's our answer. That's the sum of the first 14 terms in this geometric series over 6 billion. Right. We okay with that?
What?
So, the next one is the same idea. I need to collect these same 3 pieces of information. I need the number of terms, the first term, and the common ratio. So, my number of terms I'm given here is just 20. My first term, I can see, is 81. We're dividing by 3.
It's gone down by 54.
So how would I express that as the number that I'm multiplying by? Oh yeah, 0.33333, which would be the same as 1/3, right? So again, all we're doing is taking one number and dividing by the number before it to get our common ratio. Right? So 27 divided by 81, 9 divided by 27, 3 divided by 9. Those are all 1/3. So I can plug that information into my sum formula. So go ahead and try that here. You got syntax error. Well, try again. I believe so.
Should be like, I got 0.0365.
Your answer can't be right because 81 plus 27 is greater than 0.03. Yes, but you're adding them all up, so those numbers don't cease to exist.
I got 121.5. So if we just think about this logically,
The 20 is
right,
supposed to be
we're
inside
adding
parentheses.
at
Remember,
least
the
these
1/3
numbers
that gets
together and
raised
then
to
some
the
more.
20th power.
So our number is going to have to
You
be
have the whole
bigger
thing
than
raised.
81 plus 27. Right? So to plug this into a calculator, we need to make sure we're using parentheses. Right? As I have it written here would be the appropriate way to input it using parentheses. Alright, so let's make sure everybody's on the same page with the calculator here.
There we go.
No, parentheses, then A, then another parenthesis, this one here. Oh. You don't need that, just the other. Yeah. Then you have 1 minus parenthesis 1/3.
Alright, is everybody getting this on the calculator? I believe so. Yeah. Alright, so you guys go ahead and try the next two then. Okay, try number 3 and try number 4. Okay, it's the same type of problem. We need those same 3 pieces of information. Our n, our first term, and our common ratio. So collect those 3 pieces of information and find the sum of those terms. Yeah, that's right. I believe so, yeah. You did not get that?
I got 9.84.
Good.
Maybe it's the last verse.
Yeah. Dispatch.
What if I have it as a flash?
That's fine.
I want to make sure that.
Put your exponent in the wrong spot, so that exponent should be inside this one.
I still didn't get it.
I got negative 2,555.
Would I get much for breakfast? Yeah, I just looked at mine.
alpha and then y.
Oh, wait, that should be flipped out.
Why?
You can make a fraction that looks like a fraction. That whole line up. Now you can deal with the bottom, so you know at least that's in the right place.
225. 250.
There we go.
It could just be that some of your parentheses were messed up because it's easy to get lost in them.
Yes. The only way to check it would be to list out all terms and then add them together. You know what I mean? Like, list out 9 terms and then add them all together. Alright, for number 3, did we get 39.6875? Okay. Then number 4, same idea. My n, I'm told, is 9. My first term is 0.5. Then my common ratio, the number I'm multiplying by every time, looks like it should be 2. So plugging that information into my formula, sum of the first 9 terms will be the first term times 1 minus the common ratio raised to the 9th power over 1 minus the common ratio. And I think we get 225. Is it 25 or 55? 55.
This
255. Let's take a look.
for the big one, it might be a little easier.
Be about half of that.
All right, any questions on this so far? Sweet. Wednesday. Oh, this one not. No. Just everything that was on the review.
I won't be here. You gotta take it Monday.
Where are you gonna be? College visit. Well, when do you want to take it?
You gotta take it Monday. I take it the next day.
Thursday?
Yeah. I'll take it Thursday. I don't know you what they do.
Yeah,
Well, I'm
yeah,
not.
Thursday's fine. Then you get it.
I like this what you say.
He's just like, what am I not here?
I'll come to school if I get sick, get my car.
If you get hit by a car, you have bigger problems than worrying about your Algebra 3 midterm.
Actually, I'd like to see that one happen. Oh.
Alright, let's take a look at problems like this, where we are given summation notation. Okay, we looked at this a little bit already when we talked about arithmetic series. So, if I want to evaluate a geometric series that's presented in this way, I'm still looking for these same 3 pieces of information. I'm looking for the number of terms, the first term, and the common ratio. Well, does anybody remember how we got the number of terms? Yeah, it was this number right here. It was 25. Right. How would I get the first term? Yeah, we're just going to plug 1 into this equation. So when I do that, I have 2 to the 1 minus 1 power. So what's 2 to the 1 minus 1 power? Or 2 to the 0 power? 1, right? Because anything to the 0 power is 1. So my first term is just 1. How do I get the common ratio? Any ideas? We're not going to plug 25 in. 25 would give me the 25th term. And that's not what I want. So It's not
Two.
1. Who said 2? How'd you get 2?
What is multiplied by?
Yeah, the common ratio is just the number that's being raised to a power. Okay? The common ratio is just the number being raised to the power. Right. So now we've collected those same 3 pieces of information, just in a different way. So let's take those and plug them in. So the sum of the first 25 terms will be the first term times 1 minus the common ratio raised to the nth power divided by 1 minus the common ratio. That's what we get. Say it again. $33,554,431. Good on that one? Alright, you guys try number 6. Okay, same idea. We want to collect those same 3 pieces of information given our series in summation notation. So R is just the number that's being raised to the power. So in this case, that's just negative 1/2. Oh. I figured I didn't change that from the last problem. Yes, it starts at 6. So how many terms do we have? We're starting at 6 and ending at 20. So the reason each of these were this number is because I started at 1. So 1, 2, 3, 4, 5, 6, 7, 8. And 2. So we got 8 terms. But if I'm starting at 6, and going to 20, I have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That makes sense.
First term would have 1 here, not a 20.
Yeah, this will probably end up being a fraction. Negative 85.
No, I divided negative 85.
I don't know. I'm not sure if that's right. What's going on?
Oh, yeah.
Either way is fine. Negative 21.25.
Wait, did we have to put it in the fraction form?
Is that what we all got for number 6? Either negative 85/4 or negative 21.25?
I got syntax error.
You've been getting the same answer for a lot of these. Oh. Monster.
Guys, you're gonna like Mohawk?
Yeah.
What do you think of it? Nice place. When I was there.
Alright.
This too.
Alright, let's take a look at the last 2 examples here. On these, again, I want to collect the same pieces of information. However, on both of these, I am no longer starting at 1. Okay? It tells me the first number that I'm supposed to plug in is 6. What that means is that 20 is not the number of terms. Okay? If this number down here is not 1, and everything we've looked at so far, this number down here was 1. Okay? First term, we're going to get by plugging in 6. Okay? The first term we're going to get by plugging in 6. So we would say negative 4 times negative 3 to the 6 minus 1 power. Say 972. Okay. Now the number of terms is also going to be a little different. Right? It's not going to be 20. If I'm starting, but the first number I plug in is 6, and the final number I plug in is 20. Well, the number of terms then would be 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 15 terms. Okay? So n would be 15. Now, a little better way of figuring that out than just counting from 6 to 20. Okay? If we take the top number minus the bottom number and add 1. Exactly. Alright? That gets me, I will have 15 terms. Okay, and that'll work every single time. That'll even work for the ones that we just did. Right? And that in number 6, we went from 1 to 8. Right? So if I take 8 minus 1 plus 1, I get that there are 8 total terms. Here, if I take 20 minus 6 and add 1, I get that there are 15 total terms. Right. We're adding 1 because if we just do that subtraction, I'm not counting the first number that I'm starting with. Right? So if I just do 20 minus 6, I get 14. But when I do that, I would not be counting the first term. Right? Because we counted it up, and you said there would be 15, right? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 15 terms. So you get that, top 1 minus the bottom 1 plus 1. Right. So then my R, okay, we still get from that number that's being raised to the power. It should be a pretty big number. Yes. Alright, so to plug all this in then, we'll say the sum of these 15 terms is equal to the first term times 1 minus the common ratio raised to the nth power over 1 minus the common ratio. So So we should get a pretty large number here. I don't know what it is off the top of my head. Here, read it to me.
3, 4, 8, 7, 8, 4, 6.
Is that what everybody else got?
I don't know if it's right. I don't know if it's right.
That's what I got.
Not syntax error?
No.
Alright. Let's see.
Not this time. Oh, yeah. Yes,
I don't know if that's quite what that means.
You go to the final boss.
Alright. Questions on that one? Alright, you guys try number 8 and we're done.
So we
Right.
count number 1 is 1. So would that be right? Wow. Before I put it to the end.
Yeah.
So it's incorrect.
Yep.
No,
Should I write this or the other one?
You give me a second.
I.
Why did I get I?
What's up? Oh, that should be 81, should it? That should be.
1.5?
Yeah. Yeah, either a fraction or a decimal. Yeah. I hope you're about to do it right. Alright, what did we get?
I don't know, I didn't know.
Just put down some numbers. 80, you said 80.9 something? Yeah.
She's down.
Just write down some numbers.